Hi everybody, this is the last video covering section 2.3 where we'll be talking about some applications which require the use of quadratic equations. And here is the first one. And this one is actually a quadratic interpolation or a quadratic regression problem. And we have that an automobile tire manufacturer collected the data in the table, this table right here, relating the pressure, X, in pounds per square inch and mileage in thousands of miles. And we want to use quadratic regression on a graphing utility to find the quadratic function that best fits this data. Now you know that we've talked about linear regression and how to do that on your calculator. Well, this is the exact same thing, except now we have to do quadratic regression. And this is the data that we have to do. So the very first thing that we need to do is enter this data into our calculator or whatever you want to use to do quadratic regression. You can actually do a search on quadratic regression in any web browser, and you'll come back with a variety of pages which will calculate quadratic regressions for you. But your calculator does it as well. Now to do it in your calculator, we start off the exact same way we did when we had to do linear regression. We go and we click Stat, okay, and then we want to hit Edit, and there we go. Now, if you have data that's already in there, you need to erase that, and the way you can do that is by highlighting the label L2, hit Clear, hit Enter. Do the exact same thing for L1. Highlight L1, hit Clear, hit Enter. And now we can start entering data. Now notice here we have 28, 30, 32, 34, and 36. So basically between 28 and 36 with increments of 2. Not a problem. 28, enter. 30, enter. 32, enter. 34, enter. 36, enter. Now we need to go to L2, and now we're going to put in our mileage information. 43, 52, 55, 49, 46. 43, enter. 52, enter. 55, enter. 49, enter. 46. Sometimes it's always good just to review your numbers to make sure you didn't make any mistakes. 23, 52, 55, 49, 46, 28, 30, 32, 34, 36. Now that we've done that, we can go back and we can hit Stat. And now we want to calculate. There it is. Now we have one variable stats, two variable stats, mean, median, linear regression. Number 5, that stands for quadratic regression. That's what we want. So we want to go down, highlight number 5, and then hit Enter. Now the X list is in L1, okay? The Y list is in L2. So we have everything that we need, and we go down and hit Calculate. And that provides us with our answer. Now notice that A, this is A right here, is negative 5.89, or 0.589. Of course, we want 5892. We want this to 3 decimal places, so this is going to round to negative 0.589. B is 37.8642 and some more. Since this is a 2, this is going to round to 37.864. And then finally, C is negative 554.5142, and that's going to round to negative 554.514. And that is what we should put in here. For A, we should have 0.589. For B, we should have 37.864. And then for C, we should have negative 554.514. And let's see if I'm actually right. I'm right. That doesn't happen every day. Okay, so now we can go move on to the next one. And this is the next one. This one's a little involved, so let me just bring this down. And this is what we have. We found that marketing research for the marketing research department for some company that manufactures and sells memory chips for microcomputers established the following price, demand, and revenue functions. The price demand function is going to be 120 minus 4x. In other words, if you want to sell X number of chips, that's how much you need to charge it. And then the revenue function, which is the product of the number of chips you sell and the price, is going to be equal to X times 120 minus 4x, where PX is in wholesale price in dollars, X is in millions of chips sold, and RX is in millions of dollars. And the domain and the function ranges between 1 and 24. And the question here is, which of the following is the graph of a revenue function? The first thing we need to notice is that X takes on values of from 1 to 24. It does not take on the value of 0. So the valid ranges of X are from 1 to 24. Look at part A. Here, X ranges from -1, well, basically negative numbers. It cannot be A. Okay? Furthermore, let's take a look at C. And what you can do is you can click on this arrow right here to make C big. And one of the things that you will notice is, okay, well, it starts at 1. It only goes to 20. Okay, that doesn't seem right. Okay, and also, you cannot have negative revenue. Negative revenue does not make any sense. You're always going to be making some sort of money because we're not taking out the cost. There's no way the revenue function can be indeed negative. Okay, so C cannot be it. B is the only logical choice, even though B doesn't go all the way to 20. But since B is positive, and it only makes sense to have positive revenue, this can only be the only logical choice. And to be sure of that, what we can do is look at some of the trivial numbers. For example, what about when X is equal to 1? Okay, well, when X is equal to 1, we're going to have 1 times 120 minus 4, which is about 116, which is pretty much reasonably close to there. So with that information, you can go ahead and deduce that it is probably B. Okay? And I was right. That doesn't happen every day. Okay, then the next question is find out the output that will produce the maximum revenue. There's a couple of ways to do that. Okay, now we're looking for the output that will produce the maximum revenue. Now remember, this is a quadratic function, and the maximum is going to occur at the vertex. Okay? And the maximum will occur at the vertex, which of course is HK. This is the x-coordinate, or in this case, the number of chips. This is the y-coordinate, i.e. number of dollars. Okay? The revenue function is equal to x times 120 minus 4x. We can write that in standard form as follows. Let me get rid of this real quick. We can multiply, we can use the distributive property to get rid of the grouping symbols, and that will give us 120x minus 4x squared. And then we can rewrite that in standard form, which will be negative 4x squared plus 120 times x. Okay, with that in mind, we can figure out what h is. Remember, h is equal to negative b divided by 2a. This is b, that is a. So h is going to be equal to negative 120 divided by 2 times a, which is going to be 2 times negative 4. That is going to be 120 divided by 8. And 120 divided by 8 is 15. Okay, so 15 chips will produce for you the maximum revenue. And if you think about it, you can look at this graph right here, and it kind of makes sense. There's 15. It looks like we're at a max right there. So the answer here should be 15 million chips. Okay, let's move on to C. And what is the maximum revenue here? Okay, well the way we can figure that out is pretty much what we've done before. That's going to be K. Remember, how do we figure out what K is? Well, K is going to be the revenue function evaluated at H, which in this case is 15. And that is going to be 15 times 120 minus 4 times 15. Okay, well that's going to be 15 times 120 minus 60. That is going to be equal to 15 times 60. $15 times 60, sorry, I don't have that memorized, is going to be equal to 900. Does that make sense? Well, let's come back over here and look at our graph over here. All right. Notice here we have 100, 200, 300, 400, all the way, every single division is 100. Here's 15. It seems to be hitting 900 right there. It makes perfect sense. So our answer here should be 900. 0.00. You probably don't have to do that, but just to play it safe. If you didn't do that with the decimals and it yelled at you, just do it again. Okay, now here is what is the wholesale price per chip that produces the maximum revenue. Now let's think about this. This is the wholesale price per chip. If you produce 15 million chips, your maximum revenue is going to be $900 million. Okay? So therefore, your revenue per chip is going to be $900 million divided by 15 million chips. In other words, 15 million chips will produce for you $900 million. So this is the revenue. This is the number of chips. So the revenue per chip, I can call it RPC, is going to be the total revenue by the total number of chips produced, which will be 900 million divided by 15 million. What's that going to be equal to? Well, let's go over here to our calculator. 900 million, 1, 2, 3, 4, 5, 6, divided by 15 million, 1, 5, 1, no, it's not divided, let's bring that back over there. Divided by 1, 2, 3, 4, 5, 6 is equal to 60. Of course, you didn't end it, you could have just done 900 divided by 15. Give you the exact same thing. So we're talking $60 per chip. And there we go. And that is it for that bad boy, I believe. And this brings us to our last company, which once again is a company that does chips. I guess chips is the in thing nowadays. Now this company manufactures microchips. And we're going to use the revenue function of revenue function R of X is equal to X times 75 minus 3X. And then the cost function is going to be 123 plus 14X. And we need to answer really 9 things to actually solve this. But notice that both functions are valid between 1 and 20. And the first question is, tell me what the profit function is. Okay? Now remember, what is profit? Profit is revenue minus cost. These are functions. So the profit function is equal to the revenue function minus the cost function. The revenue function is x times the quantity 75 minus 3x. The cost function is 123 plus 14x. Okay, you can't put that answer in MML. Why not? Because they want you to simplify it. There's lots of things that we could do to simplify this. The first thing is we can get rid of the grouping symbols using the distributive property. And if we did, we would have 75x minus 3x squared. Then over here we will have minus 123 minus 14x. Okay, now we have like terms that we can combine, and we probably want to get this into standard form. So let's start off with the standard form part. We have a negative 3x squared, and that's our quadratic term. We have a like term here and a like term here. 75 minus 14 hopefully is 61. That's not a 4, that's a 5. And it is. So it's going to be plus 61x minus 123. Okay, and remember this is valid when x is greater than or equal to 1, and less than or equal than 23. And this is p of x. Okay, let's see if I messed that up or not. So let's come over here. All right, now to put this in, we'll do negative 3x. Now you can click on this thing right here and put in your square. And then you want to use the arrow to get out of that. Plus 61x minus 123. Oh, and I can see where my mistake is. I have an x up there. That should be a 2. Let's see if I can fix that. And now I can check my answer, and that's a lot better. I was beginning to freak out. What the heck did I do wrong? Okay, now, which graph below shows r of x, c of x, and p of x? Okay, now, for this part, let's graph all 3 functions on our calculator, and then let's see which of these graphs is close to the graph that we have on our calculator. So let's go ahead and do that. Okay, we're going to start off by putting in our equations. First one we can put in, I guess, will be our revenue function, which will be x parenthesis 75 minus 3x close parenthesis. Okay. The second one can be the cost function, which will be 123 plus 14x. You can delete that. There we go. And then finally, we can put in our profit function, which is going to be negative 3x squared plus 61x minus 123. Okay, once we do that, we want to mess with our window. Now notice that each of these graphs, the x values range from 0 to 20. So 0, 20. And then the y values range from 0 to 480. Okay, and now we can go ahead and graph them. And there we go. Notice that the cost function here is negative, so that can't be right. It has a negative slope. That cannot be right. In graph A, the profit function is very, very close to the revenue function right there, which is kind of inconsistent with this particular graph, so I believe that one is out as well. part B, graph B is also out because notice here the cost, the revenue function crosses the origin. This one does not, so that cannot be correct either. So the closest one that the one that I believe is closest would be D. Notice here we're crossing the origin, although we don't have a good scale there. I wonder if I can fix that. There we go. That looks a lot better. And here you can see the y-intercepts are the same or are relatively the same for the revenue. I mean for the cost. The revenue crosses the origin, and the profit. The profit starts just after this tick mark and ends just after there. So this one looks to be the closest. So let's go ahead and click this, and we hopefully are correct. And yes, we are. Okay, let's go along with it. Okay, now here we want to discuss the relationship between the points on the graphs of R and C and the x-intercepts of P. Well, let's take a look at this graph right here. Notice that when P crosses the x-axis, R, this is R, and C are the same. Right, also here, when P crosses the x-axis, R and P are the same. So when the profit is equal to 0, the cost and the revenue are the same. Kind of makes sense. You're not making any money. Of course, you're also not losing any money. Okay, so that's what we're looking for. So what do we have? Then we have that the x values of the intersection points of R and C are equal to the x-intercepts of P. They're the same. And I was right. God knows how. For part C, we want to find the x-intercepts of P to the negative 1,000 chips and then find the break-even points to the nearest 1,000 chips. So the x-intercepts of P occur at, well, to do that, we want to find out the zeros of P. All right, so let's go ahead and click the graph first. And notice that, well, these are the zeros of P, but to compute the zeros, we actually have to find some points below them. So let's go ahead and change the window a little bit. And let's make y min be equal to negative, I don't know, 50. That should be enough. And then hit graph. Okay, that's kind of like over the one. That way we can get we need to find a bound, and so we need to get below here just a little bit. Okay, now we can do second calc zeros. So 0. Okay, but notice here that right now we're trying to find zeros for the first curve. We want to find zeros for this curve. To get to this curve, all we have to do is go down to it. So come over here to our cursors and go down. Now we're at the red curve. Now we're at the black curve. Okay, and the first thing we want to do is find this 0. So we can do that by finding the left bound. And now you can see why I decreased the, made the window a little taller. So I can get below the 0. Okay, I'm below it, I can hit enter. And then for my right bound, I had to get above the 0. There we go, hit enter. And now I just click a point in between the two. There we go, hit enter again. Okay, and this is my 0. And we want to round to 3 decimal places. So my first x is going to be 2.2697, which will round to 2.270. Okay, that's my first x. Or my first 0. To find my second 0, I had to do the exact same thing. Find a 0. Go to the correct curve. All right, and now I need to find the left bound on the other side. Say right about there. Okay, now find our right bound. I had to get below the axis. Now I need to get, okay, now I need to guess. Any point in between the two will be fine. And that gives me 18.0635. So my other x is going to be 18.0635, which will round to 18.064. So these should be my two answers. Let's find out. I will have 2.270, comma, 18.064. And they are correct. All right, now the next part is, do the x-intercepts of the profit function indicate the break-even points? And the answer is yes. If you don't have any profit and no loss, then you are breaking even. So the answer here is yes. Okay, for part C, we're almost done. Find the value of x to the nearest thousand that produces the maximum profit, and then find the maximum profit and compare it to the maximum revenue. Okay, now remember, this is the profit curve. This is the maximum of the profit curve. That is the maximum of the revenue curve. They are two different points, but we want to find the maximum of the profit curve. And how can we do that? Pretty much the exact same way we found everything else. We can use the calc feature. Second calc, we want maximum. 1, 2, 3. There we go. Hit enter. Make sure we get to the right curve. Now find the left bound. We want to get to the other side of the hump. Right there is perfect. Hit enter. All right, now we want to get on the other side of the hump. There we go. That's close enough. Hit enter. And now we want to pick any point in between. Doesn't matter. Right there is good. And hit enter. Okay. This is the maximum. That's the x coordinate of the maximum, which corresponds to millions of chips. And that is the y coordinate of the maximum. So the maximum profit occurs at x. This is x, which is 10.16668. That's what x is. Okay, we want to round it 3 decimal places, so this will round to 10.167. $10.167. All right, the maximum profit right there is the maximum profit. Okay, so the maximum profit, let's just go ahead, is going to be $187.0833 million. Okay, and that's going to round to 187.083. That will be your answer for profit. All right, now our maximum revenue. To find our maximum revenue, we need to do the exact same thing we did before, but we want to operate on the blue curve. So that's going to be second calc 4 for maximum. Okay, now here, conveniently, we're on the right curve. So we just click right here for the left bound. All right, so now we just need to come over here to the other side of the hump. There it is. That's our right bound. Any point in between is perfectly fine. And it turns out that our maximum revenue is going to be $468.75 million. No rounding needed, because we're rounding to 3 decimal places, but it terminates at 2. So that'd be 486.75. You can check my answer. There it is. And this, I believe, is our last question. The maximum profit is it greater than the maximum revenue? Is it smaller than maximum revenue or equal? Well, obviously the maximum profit is going to be smaller than the maximum revenue, because the profit is going to be revenue minus cost. And there you go. And that is pretty much how you do every single problem in the third homework assignment for this particular section. Once again, to do this, it really helps to have a calculator. There are graphing tools on the internet that you can use that will help you, such as GeoGebra or this thing called Desmos. But I would really encourage you to purchase the calculator if you haven't done so already, and practice with the calculator, because you will see some of these problems not necessarily in this homework, but on your exam. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.